Hi, this is Shay Jackson with Hype Math. In today's video, we will be going over the independent practice questions for getting ready for Algebra I, Math Concept Real Numbers. To follow along, there will be links in the description box where you can purchase a digital copy or a hard copy. Before we get started, don't forget to hit that subscribe button. Also, to receive notifications, hit the bell. For our first problem, we are graphing the numbers on the number line. We have 3, the square root of 10, 3/4, and negative 1.5. Our first step before we're able to graph these numbers is to change them all in the same form. Now, before I go on, all of this information that we are going over is in a review section and also a guided practice section as well. So once you get to the independent practice section, you've already had enough information so that you can answer these questions. When we are changing all of the numbers to the same form, the best form I would like to use are decimals. So let's look and see what all of these numbers converted to decimals look like. Okay, for our 3, we don't need to change that into a decimal because it's a whole number, so it'll stay 3. The square root of 10 is equal to 3.16 or 3.16. 3/4 is equal to 0.75, and negative 1.5, that's already a decimal, so it will stay negative 1.5. Let's take a look at our number line to see where each of these numbers will be graphed. In looking at our number line, we see that we have from -2 all the way to 4, and all of our numbers are in between these two numbers. Our negative 1.5 is in between -1 and -2. 3/4, which we know converted into a decimal is 0.75, is closer to the whole number 1 because it's 0.75. So it's between 0 and 1. Our 3 remains 3, no biggie there. And for the square root of 10, this square root, when changed to a decimal, is 3.16. So this, when graphed, it's between 3 and 4, and it's a little after the whole number 3. Let's move to our next independent practice question. Graph the numbers on the number line, and the numbers we have are 2, negative 3/7, negative 1.5, negative 3/2. And of course, we said before, the first thing that we need to do is change all of our numbers to the same form. What form are we going to use? Decimals. Let's take a look and see how all of these numbers and all of the numbers are converted into decimals. Again, if it's a whole number like our number 2, you don't have to put 2.0. It's a whole number, so you leave it as 2. For negative 3/7, that is equal to negative 0.43. Negative 1.5, it's already a decimal, so it will stay negative 1.5. And negative 3/2 converts into negative 1.5. So we have two numbers that are equal to negative 1.5. Let's take a look at the numbers in the number line or on the number line. All right, so if you look between -2 and -1, in the middle we have negative 3/2 and also negative 1.5, because again, both of these, when converted to decimals, the negative 1.5 was already a decimal, so it stayed, but the negative 3/2 converted to negative 1.5. So both of those are on the hash mark, negative 1.5, or on the tick mark. For moving along, getting closer to the 0, we see negative 0.43. That's between -1 and 0. And we have 2, which is by itself on the positive side of the number line. Let's move to our next independent practice questions. For this section, the student is given a square root and you have to tell which two integers is in between, okay? You're giving a square root and you have to tell which two integers that square root is in between. So starting with the square root of square root of 92, what two integers is this square root in between? Now, in the guided practice section, there is a chart that shows all of the perfect squares from 1 to 15. And so whenever you're doing the independent practice, you can look back there as well. But let's see what you can do now. If you said that the two integers are 9 and 10, you are correct because the square root of 92 is in between the square root of 81 and the square root of 100. Let's move to the next square root. The square root of 45. So think about what two integers this square root is in between. If you said 6 and 7, high five, you are correct. Because the square root of 45 is in between the square root of 36, and we know the square root of 36 is 6, and also the square root of 49, square root of 49 is 7. So those are the two integers that the square root of 45 is in between. Let's look at another square root. The square root of 107. So think about what two integers this square root is in between. If you said 9 and 10, you are correct again, because the square root of 107 is in between the square root of 81, which we know is equal to 9, and the square root of 100, which is equal to 10. Let's move to our next problem. The square root of 63. Which two integers is this number in between? If you said 7 and 8, great job, because the square root of 49, which is 7, and the square root of 64, so it just barely made it in between 7 and 8. Let's move to our next square root. The square root of 152. Which two numbers or which two integers is this square root in between? If you said 12 and 13, you are correct, because the square root of 152 is in between the square root of 144. The square root of 144 is 12. And the square root of 169, and the square root of 169 is 13. This completes our section of finding out which two integers the square root is in between. Now we are going to move to the independent practice, where you can use a calculator to input a square root to find out what the square root is to the nearest hundredths place, okay? So for our first two square roots, we have the square root of 200 and we have the square root of 44. Now, again, for this section, in the guided practice section, we talked about how to enter it in. Now, if you don't have a calculator, Google scientific calculator, which is explained in the guided practice section, and you can use that calculator on Google in order to find out the numbers for these square roots, okay? So we have the square root of 200 and the square root of 44. We are going to round our numbers to the nearest hundredth. That means 2 places after the decimal point. And just in case you hadn't used the scientific calculator before on Google, this is what it looks like. All right, so for the square root of 200, on the left-hand side, we see that our number will be 14.14 because, again, we said we are going to round to the nearest hundreds place. And for the square root of 44, our number will be 6.63. Let's move to the next two numbers. We have the square root of 437 and the square root of 625. When putting that in the handy dandy calculator, for the square root of 437, our answer will be 20.9 or 20.90. If you want to put the 0, you can, but it's really not necessary. I know we said we would round to the hundreds place, but whenever there's a 0, you really don't have to write it. So our answer would be 20.9. And for the square root of 625, our number is 25. This is a perfect square. Let's move to our next two square roots. We have the square root of 87 and the square root of 101. For the square root of 87, our answer will it be 9.32 or 9.33? You're correct. It'll be 9.33 because if we look to that thousands place, there's a 7. Since there's a 7 is greater than 5, we are going to round that to up to 3. So our answer is 9.33. And for the square root of 101, our answer will be 10.05 because looking over to the right, there's a 9 close to the 4. And we need to round our 4 to 5. Let's move to our next set of square roots. We have the square root of 95 and the square root of 8. Put it in your calculator right quick. See what answer you get. For the square root of 95, our answer is 9.75. Again, because we need to round that 4 up. And for the square root of 8, our answer is 2.83. Just a couple more. Stick in there with me, guys. For the square root of 56, and we have the square root of 315. We can use our calculator. Oh, and what a good thing would be, so let's say that we are putting in our calculator. And I know when you have a calculator, it's easy to not do what I'm just about to say. But in our previous exercise, we thought about, okay, what two integers was the square root in between? So let's do that for the square root of 56. So I'm going to say that the number should at least start with a 7 because the square root of 49 is 7 and the square root of 64 is 8. So the answer for the square root of 56 should be 7 point something. For the square root of 315, I think it should be maybe 19. It should be 19 point something, maybe because I know the square root of 400 is equal to 20. So let's see. Oh, I was wrong. For the square root of 315 is actually 17. I was wrong. So it's 17.75 for the square root of 315. But the one for the square root of 56, I did get it correct. It's 7.48. Okay. And again, when you are calculating, because it's easy when you're using a calculator to quickly type in the numbers, just take a moment to think, okay, what integer or what number is close to the square root that I'm trying to find? Okay, last set of square roots, the square root of 738, I'm not going to even try that one, and the square root of 225. When we tap that into our calculator, and just to say again, you can, if you don't have a calculator, you can Google scientific calculator, and it's in the workbook, how to look for it and how to work the calculator. It's pretty simple, but if you don't have one, that's a great way to do the exercises and do homework as well whenever you go back to school. So for the square root of 738, our answer is 27.17, because we have to round that 6 up, and the square root of 225 is a perfect square root, and our answer is 15. This concludes this section in calculating the square root. Let's move to our next section concerning scientific notation. So for this problem, or these problems, you have to write down the scientific notation for the following numbers. We have 6,400,000, 183,000, 0.0000008, 529, 9,109, and 0.000034. Okay, and just to reiterate, or to say again, for the independent practice section, it's just going over information that was in a guided section area, a review section area, and also guided practice, just to make sure that you fully understand before moving to this section, okay? And also, these answers are in the answer key in the back of the workbook, in the answer key section as well, but it's good just to hear somebody walk through it with you, as opposed to just looking and you're like, well, how did she get that? Well, how do we get that answer? Just walking through those independent practice questions with you can kind of help you to understand how that answer came about. All right, so let's look at our answers. For 6,400,000, our scientific notation is 6.4 times 10 to the 6th power. For 183,000, our scientific notation is 1.83 times 10 to the 5th power. For 0.0000008, our scientific notation is 8 times 10 to the -7, and that's something we talk about in the review and the guided section as well, okay? For 529, our scientific notation is 5.29 times 10 to the 2nd power. For 9,100, our scientific notation is 9.1 times 10 cubed, or 10 to the 3rd power. And lastly, for 0.000034, our scientific notation is 3.4 times 10 to the -5th power. Now let's move to changing our changing our scientific notation to standard form, okay? So for our first problem, we have 1.5 times 10 to the negative cubed, 10 to the negative cube, or 10 to the -3, 4.6 times 10 to the 5th power, 3 times 10 to the 7th power, 8.2 times 10 negative squared, or 8.2 times 10 to the -2nd power, 7.7 times 10 cubed, or 10 to the 3rd power, and 5.8 times 10 to the -4th power. All right, let's look at our answers. So for 1.5 times 10 to the -3rd power, our standard form is 0.0015. For 4.6 times 10 to the 5th power, our standard form is 460,000. For 3 times 10 to the 7th power, our standard notation is 30 million. For 8.2 times 10 to the -2nd power, our standard notation is equal to 0.082. For 7.7 times 10 to the third power, our standard notation is 7,700. And lastly, for 5.8 times 10 to the negative fourth power, our answer is 0.00058. We made it. Thank you so much for staying to the end of this video. And just to let you know, we're having a sale on all of our Getting Ready for Algebra 1 books. The digital copy is $3.99 and the hard copy is $12.99. And that ships within 2 to 3 business days within the U.S. only. Again, if you want to see more videos, don't forget to hit that subscribe button and hit the bell to be notified of all math videos or some reading as well. Getting ready for third, we do third all the way up until 9th grade, getting ready for the next school year, or just to reinforce those math concepts that you or your student may have. This has been Shay Jackson with Hype Math. Talk to you soon.